Hi class, 5.4 we are going to study about theorems about definite integrals. So I want you to see the differences of definite integral and indefinite integrals. Definite integrals are the one we have domain from A to B. So when you have an area to find base times the height, you can find the area under the curve exactly A to B. Then indefinite integral is going to be just without the boundaries, just so everything of the function. For example, if you write it this one, probably from left side and the right side, just adding all those things as area. So if you look at the graph, basically they are talking about all this thing. The whole this thing. But now, do you see that what will be the answer? It will be 0. Why? Because it's going to be odd function. So it cancels out top and bottom. So there will be a lot of intuitive properties you will see through the 5.4. So just I want you to enjoy and then look at the graph very carefully. So example 1 of the appetizer. Here says the area from 0 to 1.25. Area from 0 to 1.25 cosine x squared function kind of look familiar. You guys did some activities earlier too, right? So when you see this function, here says this is a 0 and then this is the 1.25. Then what they is telling me is the area is 0.98 under the curve. So if you look at the graph, this is the area 0.98, and then now there's a cosine 0 to 1. 0 to 1 will be slightly smaller, so up to this one. The markers are showing one. So up to this one, then that's going to be 0.09. So let's careful. Whole thing is 0.98 and then up to 1 is 0.90. So what are the values of the following integrals? So just look at here. From 1 to 1.25, what will be? The area differences will be 1.25. Subtract 0.9. So think as many, then you are going to have 0.35. Okay, keep thinking about here now. How about negative 1 to 1? That means as even function, if I know this area, do you see that I can double? So B, if you look at carefully, that's going to be from 0 to 1. I know that that area is 0.9. And then as you see, this is an even function. So other side will have exactly same area. So times by 2, go to 1.81. Oh, not 1.81. Yeah, 2 times, right? And then C, how about 1.25 to negative 1? Uh-oh. Do you think we can find from negative 1 to 1.25? Yeah, that will be negative 1 through 0. This area is going to be 0.9 plus 1.25 is 0.98. And if you add it, it's going to be 1.88. So from here, from negative 1 to 1.25 was 1.88. Then what's your guess? If I have inverse of your domain, 1.25 to negative 1, then we will write our answer as negative 1.88. So just remember, if you just take the integral other way around, then you will get negative. It makes sense, right? Intuitively. So now I want you to look at the graph of the in-class activities and find the area under the curve of the given domain. Okay. Okay, how did your in-class activity go? Hope that you're understanding the concept okay. Still, if you cannot do it by hand, finding antiderivative, just keep practice with me. So let's look at the graph here. First one, answer 1, 0, 1, 2 pi. Just look at the area under the curve. And as you see this one, you cancel out this one positive, negative. So it has to be 0. Therefore, 0 to 2 will be just adding these two values as 1. And then next one, 3 to 7 is a half circle, so half circle is a pi r squared divided by 2. I got 2 pi right there. Now in class activity 3, should be 2. If you look at this one, by graphing, I count the area of the box and then that shows me 8 as area. Also, we can use the fundamental theorem of calculus, which means we will find the antiderivative, and from there 0 to 2, I can compute those two numbers, and then I got 8. So keep getting familiar with this one so that you get to practice more. Good job, class. So let's look at our main dish. As I mentioned, 5.4 is just about some properties of integrals. So let's look at what happens if your function is even function like this. Then do you see that I can find the integral from just 0 to a, and then I can double this value because this is even function. Why do you have to double? Well, because sometimes it's easier to plug in 0 than plug in a and negative a. That's what we try to use. So sometimes easier to use a 0, so it doesn't have that, and then twice of the area if it's even function. Then what about odd function like a sine function? Then as you see, if the area under negative a to a will be cancel out positive the area negative this area, so eventually it will be equal to 0. So if you look at the properties here, if function is even, then look at what's your domain, a to a, negative a, then your domain, your area will be twice off from 0 to a. If it's odd, then it will be 0. Does that make sense, right? So if you can remember, that's good. If you can get it through the thinking, that's very good too. So let's look at example of the textbook. Here says given that from 0 to pi, sine function is equal to 2. So let's just briefly graph our sine function so that we can feel a little bit. So this is a sine function, and then 0 to pi, this is going to be 0 to pi. This area is a 2. Actually, it is a 2. Don't you think it's a really nice number, right? So 0 to pi is a 2. Then what would be negative pi to pi? So what would negative pi to pi? This time, do you see that it has to be equal to 0 or twice? It's going to be 0 because the sign is even function, odd function. It is odd function. So it's going to cancel out. How about if I put absolute value of a sine t? What does that mean? That means a net area. So this case will be 4 because this area is a 2. And then since I put the absolute value, this area is also 2. So total is going to be 4. So I want you to see when we use this one, that's like total mileage kind of a story when we use, and then this one is the shortest distance we travel. So displacement, and then this is the distance. We talked about that before, so careful what this means. Okay, class, so let's talk about our main dish number 2. You will see that how cool integral is. Before, until you learn about calculus, we cannot find the area loop has a shape like this, but now using the calculus you can find the area. So if I want to find the area here, we need to see that where my rectangle will be. So this will be my rectangle, right? Then I know that the base will be dx, and then height, what will be the height? Without the other one, this function, the height will be f of x. But now, do you guys see that I want to find the height? This will be f of x function, subtract g of x. So the height will be f of x minus g of x. Okay, so basically, I want to find the integral from a to b, those intersections of the height is going to be subtract these two. Everybody hope that makes sense what I am doing. Subtract negative x squared plus 4x minus 1, subtract x squared plus 4x minus 5, and then don't forget the x. So before we do, what do we need to do? Well, you can take an integral and then simplify, but we need to find what a and b value will be. So let's organize negative x squared, 2x squared, and then plus 8x and minus 6, and then what will be those 2 points? Do you see that? What are those points? Same x value, same y value. So can I set f over x equal to g over x? Yeah, because they have the same x value. So set equal to each other. So we are going to do system of equations. Bring all of this equation to another side. That will be, I'm gonna bring it and then add together. That will be 2x squared minus 8x, and then plus 1 plus 5 plus 6. So if I set this one equal to 0, I get same equation. And if I factor it out by 2, I get x squared minus 4x plus 3 equals 0. Oh, I see the factor x minus 3, x minus 1. Awesome. So from here, I found x is 1 or 3. What does that mean? I found these two equations that shares the same x value, which is a and b. What are they? This a value is going to be 1, and then b value is going to be 3 by solving system of equations. So this whole thing I can rewrite as a 1, 2, 3. However, in order to make the derivative, it will be easier to take out negative 2. So I want to take out negative 2, and then let's take a derivative of x squared minus 4x and plus 3 dx. So this is easier than taking antiderivative of this one. That's what I try to do. So negative 2, let's try to take a derivative. What would that be? This is a little bit tricky and then comes from multiple practice. 1/3 x cubed. Just what I do, I just take a derivative. Then try to see if I get same thing. So I have a 4x, then it comes from x squared. But if I want to make 4x, it has to be 2x squared plus 3x from 1 to 3. I'm almost there. So let's plug in. Okay, I'm going to deal with negative to very end. So I'm going to deal with this part first. So let's plug in 3. Then 3 said 3 cancel out. So I'm going to have 9. So I'm kind of making my algebra a little bit, doing 2 steps at a time. So that will be 9 minus 9 times 2 is 18 plus 3 times 3 is 9. Okay, now subtract. After plugging 1, that will be 1/3 minus 2 plus 3. And don't forget, we still have a negative to very beginning. Interesting. Hopefully, I didn't make mistake. So as you see, they all cancel out. So that's a 0. And then next one will be, I'm getting negative. That will be 1/3 plus 1. So that makes, and I have the negative 2. You can actually make more better space. So that makes a 4/3. The negative makes positive. Times 2 makes 8/3. Okay. 8/3 is going to be about 2.2 and 2/3. So 2.666. Okay. How you know if your answer is correct? You can actually punch into decimals, right? You guys know. Sorry, I squeezed a lot here. And now I'm using my system of equations and then fundamental theorem of calculus. I found the area of this shape turned out to be 8/3, which is 2.66. Pretty cool, right? Now what you can do. So hope that this was a good exercise for you, and then see why you learn all the math. It comes here, and then it comes to explain calculus. So keep enjoying, almost there. So on our dessert, we are going to see and find how we're gonna find the average value when the function is a continuous. If the number is a discrete, like your exam score. So if you want to find your average exam score, let's say you have a 90 plus 85 plus 95 and divide by 3. You have those 3 numbers and divide by 3. However, this is discrete, but in calculus, all those numbers will be continuous. So in this case, how do we find those average value of the whatever given those integral function here? So let's look at example. Dessert 1. Suppose that C of T represents the cost of heating of your house. So how much, that's just basically the electric bill, just think about PG&E bills, and measured in dollars per day. So this is measured in dollars per day. Then where T is a time measured in days, and T started from the first day, that is 0. So correspond to January 1st of 2008. Then what would be integral of 0 to 20 CT dt means? What would this mean? So do you think this means $1 per day of your cost, or is it going to be dollar? I want you to distinguish the differences. So this will, they say $1 per day as I put it. Then times, what is this one? That's going to be day, right? So what happened is going to be cancel out. So my integral is going to be telling me what is the total amount of your heating cost the last 90 days, or the accumulation of the bill. Then what if I'm dividing by 90? Do you see that basically they're dividing by 90? 90 minus 0. Those are 2 days of differences. So after that they dividing by 90, they will, as you see, per day cost. So this one, and then you are going to divide by day. That will give me per day cost. So this will be the price of the per day, and then the other one is going to be price for the whole the 90 days. So if you divide it by this number, and then without it, that's going to be just total amount of the PG&E you spent last 90 days. So I want you to see the differences, and there's in-class activities. I want you to pause and keep think about it. As you see, once you understand, it's really easy, right? So calculus is like that. So keep thinking. Okay, let's compare in-class activity answer. So I got my answer to 2.937 millions as my answer per each year. Okay, so let's talk about here. What does this function mean? That's the number of population you will show. So if you take the integral from 0 to 20, that means you're adding all those population of the last 20 years. So think about it, is it really helpful? No, but it's like finding the average. You're just adding all those numbers, and then last 20 years, you are going to divide by 20. So 20 years of all this sum of the population, I got 58.7483, and then divide by 20, I got 2.939. As a million people per last 20 years. So average, what's the population? It's about 2.93 million if you think as last 20 years. So that's how you find and utilize the calculus and then integrals. So you can use actually decimal calculator when you do homework, because I do not expect that you can do all those fancy hard antiderivatives yet until I'm gonna introduce a 6.2. So you guys are gonna do 2 techniques, just a basic technique, and then 7.1 another substitution, and then we will finish this semester. After that, you will continue a lot of fun integrals in calculus 2. So good job, class, and then use the decimal calculator, and I will talk to you in next class.